Welcome back, everyone, to day 2 of the In Focus DevOps Week. My name is Jenny Ouyang, Principal Technical Enablement Architect, and I am your host for the week. This is a really special topic because in my years at GitHub, DevOps has always been a much talked about and much debated topic. And I'm really honored to be the host for this week's session as we get to speak with so many experts on this topic. I think conservatively speaking, the experts here today or this week have more than 100 years of collective experience on DevOps. So I'm super excited for everything. Yesterday, we took a look at what powers a successful DevOps program, the challenges faced in adopting DevOps, and how a unified platform helps to solve these challenges with Jared, Jürgen, and James. Today, we'll be hearing from Bryan Liles, Principal Engineer at VMware, and Jamie Jones, Principal Architect Director at GitHub, on their experiences in the industry with a fun and provocative conversation about DevOps of today as well as tomorrow. On to some housekeeping items before we get started. If you have a question for Jamie or Bryan today, please be sure to drop it into the Q&A tab. We will be addressing your questions throughout the session today, so feel free to ask them as they come to mind. And if at any time you'd like to have a deeper dive on all things GitHub, just click on the purple button on the top right of your screen, and we'll reach out to schedule a meeting with you. And here are some tips on optimal viewing experience. Be sure to join us from your desktop. We recommend using Chrome or Safari. Firefox works as well with the most current version. If you aren't able to see the stream, please refresh the page and disable any VPNs or ad blocking software during the session, as they may also impact the stream quality. If you need help troubleshooting issues for the platform, please navigate over to the Docs tab on the far right and select the Help document, or email our partner Goldcast with support questions. Again, be sure to drop your questions in the Q&A box for a chance to be answered throughout the entire session today. All right, let's move on. It gives me great pleasure, and I feel so very privileged to be introducing our speakers today. Jamie Jones is our Director of Field Architecture, board member of Finos, aka the FinTech Open Source Foundation, and he is someone I work with very closely with and look up to as well. Jamie is passionate about software, open source, enabling others, and modern best practices, and also mentor to many, both internal and outside of GitHub. Next, Bryan Liles, Principal Engineer at VMware. Over the past quarter century, Bryan has worked in building all aspects of what is now known as the cloud, from ISPs to early web hosting to the team that brought the first SaaS solution to the market and helping building a large cloud. Bryan has been at VMware for 2 years. And outside VMware, Bryan is focused on building communities, building and racing cars, and finding the next best movie to watch on TV. Bryan is not only skilled at writing software, but he also has a way with words. So be sure to follow him on Twitter at Bryan with a Y, that's BRYANL, and get ready for some fascinating and just thought-provoking words of wisdom. So without further ado, let me hand things over to Jamie and Bryan.
Thank you, Jenny, for the introduction. I think you covered about everything other than my dog, right? I have a dog that typically will follow me and run behind my meetings and videos. Luckily, I've locked the door, so there should be no appearance from Franklin today. Bryan, thank you for joining us as well. Looking forward to this conversation. Let's get started, right? DevOps, it's a thing. It's been a thing for a while. I came to GitHub. I've been at GitHub for just over 6 years at this point. Came from working with the US federal government. So a software developer, project manager, technical architect at times. And I feel like I grew up in the reality of DevOps, right? Where truly my ops team sat on the other side of a cubicle wall from me. And when we were ready to deploy or had bugs we had to fix in production, various fires, we literally would scream across the wall, hey, we need to take something to production and work together with them. So I feel like I experienced DevOps, from from us, right, the full journey of how we get from nothing, how we get to a wall, to how we get to actually working together as a team. I guess as I open this up for you, Bryan, how is what I did 8 years ago what DevOps is today, or how is it not? What's changed between that? We're still calling it DevOps, right? What's changed?
Okay, so let me take a little foray and try to explain this using science. So we're going to have a short quantum mechanics lesson here. And we get down, we have an atom. Let's say a hydrogen atom. It's simple. One electron, one proton. And around the proton is an electron. What is that electron? Is it a particle or is it a wave? Scientists don't know, or they say that it operates in both. If it's measured, it's a particle. If it's not measured, it acts like a wave. And I like to liken that to DevOps. DevOps is not a thing. It is multiple things. It's a way of approaching the world of software versus operations. It's a set of methodologies that is put together in things like SRE. It's a job title. It's a book title. It's something that we can talk about where we can basically place a conversation in a certain area. And that's the weird part about DevOps. DevOps is all these things, but what DevOps is a vehicle, a tool, something that has aligned us to actually stop working harder, but work smarter in the ways that we are moving to get software to production. So like things like CI and CD, things like other pipelines, using GitHub, using an SCM to store your code. That's what DevOps is. But it's also things like an SRE land where, you have how do we actually run software at scale. So that's what I think DevOps is. I know people like to share the elephant, everybody, the blind people touching an elephant, they all think it's a different thing. But, I talked to the people who created the term DevOps, and they've been able to tell me, it's what you think it is. So that's where we are.
So I don't know about you, right? When I'm talking to customers and when I'm talking to user groups or whatever, everyone said, I want to get DevOps. But how do I buy a DevOps? So you just described DevOps as an idea. What then, if you were implementing DevOps, what does the implementation of DevOps look like to you?
Okay. Wow, that's a hard question because it's something that I would charge people money for normally. So let me give you the free answer here. What is DevOps? Well, if we break the term down to dev and ops, it's all about some kind of synergy between development teams and operations teams. And it's more about moving software from an engineer or a developer who's written it to production. So DevOps describes the feelings, the activities, and the people that are required to move these things in. So, how do we employ DevOps? Well, first thing I would tell you to do is Gene Kim has written 2 books. What do you have? The Phoenix Project and the Unicorn Project. They're both fiction, so you can learn something while reading fiction. Read both of those. But what you should look at is you're looking at, instead of making the process of delivering software a people problem, someone else's problem, you're aligning everyone to rotate around a single process. So we check in code and we don't keep it locally on our desktop. We use things like CI to integrate software so that we know we only have good versions of software available. We use continuous delivery practices because humans suck. That's a weird thing, and we think that we're great, but if you look at us, we're not great. We're awful, and we're especially awful at software. And we like to think, I'm done. I throw it on someone else. Well, let's actually automate that process. So let's continuously be able to deploy or deliver software to an environment whenever it needs to go, whether that's now or in 6 months. So that's what DevOps is. And depending on who you talk to, so I used to work at Capital One, we had something called gates, and there was like 16 of them. And I'm not going to recite them because I didn't agree with all of them. but it was a practice that got us from here to there. Or, read the Google SRE book. So do these things. So you notice I'm not saying exactly what it is because it isn't a thing. But I spoke at the DevOps conference in Ghent nope, we didn't do anything last year, the year before last. And I can now say that I'm authority on all things DevOps.
So we mentioned DevOps, but you also mentioned another term in there, SRE, right? Is SRE DevOps? Is SRE the next DevOps? How does SRE relate into this whole environment?
Okay, so the SRE is DevOps. In the Google SRE book, they actually say that there's actually a sentence in there that I believe that says that SRE is an implementation of the idea of DevOps. Now that book is for Google and it's for Google Scale. So they actually have engineers. They're not even really, they're operations and engineers people who can take an application and work with it, whether they're actually improving the application or improving the infrastructure to make it run and be resilient at scale. Lots of other companies have taken that title, and sometimes they're just sysadmins. I don't know. Why did that word go away? I like the word system administrator. That was a good one. But SRE in other places is more of it's like it's an implementation. It's a flavor of DevOps. It's in some cases it's opinionated. Sometimes it's only used to inflate salaries. But SRE is more about when we're thinking about, we're serious about DevOps, because all SREs are very serious. At Capital One, they even had badge jackets. So that's what the difference is. But to be more serious, whenever we think about SRE, site reliability engineering, we're thinking about deploying applications and not engineering the application code, but engineering the reliability of this application. Now, does it need to be up? Do I need more nines or do I need more throughput? And that's what the SREs are focused on.
So many ways I can take that. Let's go the first way, because we're talking about Google. We're talking about SREs. How do you measure successful DevOps? And of course, just like you've said, there's no one size fits all for DevOps. There's no one size fits all for companies. Everyone's context matters. The people on your team, the humans interfacing, like DevOps is at its core how humans work together, right? So your humans matter, but we still need to measure things, right? How do you measure? Where do you start with measuring DevOps?
Well, so I think it's like anything else. So any business problem can be broken down. I have this theory on business problems. So you have a vision, and then you might have multiple missions. That's how you break it up between teams. All those teams have goals. The goals are satisfied through strategy, which are then we do tactics. So tactics, strategy, goals, mission, vision. Now, at every single point, how do we know that we're successful? It's because we measure. And how do we measure? I can give you a couple of different ways. One is we have applications themselves. They should be exposing metrics, and they can be pull or push. Whatever what feels good. You can actually establish a baseline, so you know that. So in DevOps land, what do we use? We use the RED method. So request, errors, duration. That's from Netflix. We have use, which was utilization, saturation, and errors. And then we have the 4 golden signals from Google, which I never choose to remember. I just know if I need to go look it up, I can.
Latency and throughput and something.
And QPS, yeah, right. QPS. And so this is for your application. You should have these numbers for everything you consider important in your application. And so you're measuring your application. But not only are that, you're actually measuring your process as well. So what does that mean? Well, you should be measuring, tallying and measuring how many commits you have. Why will we do this? I'll tell you in a second. You should measure how long your CI process takes. You should measure how long your CD process takes. You should determine how many errors come out of any of those processes. You should be measuring regressions that you track in your trouble ticketing system, whether it be Jira or GitHub issues or anything else. Now, why do we want to measure that? Well, because if you want to actually say how good something is, we don't want to be subjective. We want to be objective. And the only way we can be objective is that we have data to actually say if we're doing bad or good. Now, if you see a problem in your organization or wherever you're working, and you'll see that, am I doing bad or good? And you can't determine that, it's because you're not measuring something. And so I first tell people, you got to measure everything. And once you have that piece of automation in there, you're going to have incentive to keep those numbers, because your execs can look at your numbers, you can look at those numbers, and humans are really good at this, at gaming systems. So if you have a good set of numbers, you will work to game those. You will actually game those. Yep. So that's how I look at this.
You talk about measuring, right? Back when I was slinging code on a regular basis, right? I did a lot of monitoring, right? And we used tools like Nagios and others to like looking at like raw system stuff. But that's not what I hear today, right? I hear about observability, right? So when you talk about measuring, do you think monitoring? Do you think observability? What do you think are the differences? Where do you see the state of measuring today?
Okay, so if you're successful enough in your career to buy a Porsche, and you go into a Porsche dealership and you go to the dealer guy and you say, or girl, or whoever, and you say, I want to buy a 911. I want to buy a 992 911 Turbo S. This car, just for reference, starts at about $200,000 US. At that point, it's not like buying a car. The dealer is actually going to paint it as an experience. And this is something that I like to bring back to the word observability. It's an experience. At the end of the day, a Porsche is a car. It has four wheels. At the end of the day, someone had something to sell, so they invented the term observability. Is it a bad one? Yes, because it's long. And I know we can shorten it, like, what is it, like the O17S? That's dumb. So that's just my opinion, though. And no disrespect to anyone who invented that term, just my opinion. But I think that we've turned it on observability. And why did we do that? Well, because the word monitoring lost its meaning. I can think back many years ago when we had NetSaint. And NetSaint, you had agents, and you set these agents up, and you had to use Perl, and it was kind of confusing. And then someone actually said, "Hey, NetSaint is a thing. We got to change the name." So it changes to Nagios. And this is probably 20. Oh my God, I'm old. 21 years ago, I think it was about the time that NetSaint went to Nagios. About 20 years ago. And what happened is that we put so much effort into configuring NetSaint and the rest of these monitoring tools that we actually lost the focus of what we were trying to do. We actually focus on these tools more than the things we got out of these tools. So observability allows us to refocus those terms. So when we think about observability, we think about metrics, things that our applications are telling us, counters and gauges and histograms. We think of logging. These are human readable things our application is telling us. They stream out. We think of traces, and these are computer generated thing. Your computer system is either complex in itself or complex in a distributed way. And now we can actually look throughout. And what observability does is it puts all these things together and gives us new words to talk about these things. But I go back to, okay, I don't use observability. I just call it metrics monitoring and logs and tracing. But don't let that fool you that this is something new. We are still doing the same thing we've been doing years ago. I worked on sites in the 90s that are probably bigger than your installation that you are working at today. I probably guarantee it. We have not invented anything. We just invented new ways to talk about it.
Well, the other key thing we've done, though, is we got it to end in ility, right? Which is clearly a key piece of making DevOps successful. When we think about DevOps, you hear things like scalability, availability, observability, as we just discussed, usability, operability. I'm sure there's 100 other abilities. What is your favorite? I'm sure you have a hot take. What's your favorite ability? And what's the ility that has not yet been defined but is coming next?
The objectification of words in tech is a pet peeve of mine. Mm-hmm. But what is coming next? I think what we need to think about next is not getting bigger, but thinking about the smaller. We should be able to design these large distributed systems, and we should be able to have some representation of them on our desktop. So we should have tools for developers and operations focused people to make designing these larger, more complex systems easier. I work a lot in Kubernetes, and people complain about YAML all the time. And here's the thing. YAML is just the language. It's not for humans. It's just a language that is human readable. And people get tossed on that. They say, why is Kubernetes so complex? Well, when's the last time you asked why your operating system was complex? Even you Linux users, and I'll actually focus on the Linux users. When you want to get your Linux box configured and you have to lose a VPN, that's going to be hard. Back in the day, whenever we had the video card, that was hard. But now we don't complain about that anymore. We complain about Kubernetes like it's hard. Linux was hard. I've been using it since the beginning. And it's grown and it became stable. Everything big and important will have to grow and become stable over time. So, that's my pet peeve, is that we complain about things that we don't understand instead of saying, hey, you know what? There's things that we don't understand. And I just want to actually just shout out to Chris Wooten. Your BMW M2 Club Sport is nice, but we're talking about grown-ups cars here. So thank you very much.
We talk, you like a couple things I want to go talk, like we think about, you mentioned Kubernetes, right? So will grow up to not be a heavy configurable thing that people think of as complex. Some of that takes me back to the notion of like a commoditization curve, or like an S curve, right? Of what is unique and what is new eventually becomes standard and easy and commoditized. That's why AWS is running 8 million services right now and adding another million as we're having this talk. Where do we go? Where does Kubernetes go? Is it along the platform that we care about, or does it become just a platform, just another piece of the tech stack that's not highly relevant?
Well, it becomes another piece of the tech stack.
Yep.
Kubernetes is a platform for building platforms. So far, we haven't figured out what those platforms that we want to build, so we just start with Kubernetes.
Yep.
It's the same thing as starting with Linux with no distribution. You just have a kernel. Doesn't do much. And then in the early days, in the 90s, we got Slackware and we had Red Hat, and they made it easier. Now with Ubuntu, I can install it on any random laptop, and guess what? X works. You never had to configure mode lines. I actually wrote a whole windowing system in another lifetime. That stuff was hard, and we don't have to do that anymore.
Yep.
But it took time for us to, first of all, and this is actually the key for everything, is that we don't understand the problems that we have in front of us. We just want solutions. So we're trying to take the solutions that we have now, and we're leading them like those are the actual problems, and there's an impedance mismatch.
Yep.
And that makes everything hard. So what we need to do is apply more of a systems thinking to pretty much everything we do, and understand that, hey, it's fine that we don't know the problems that we are really trying to solve, but we will work these solutions until they're no longer useful, rather than having the golden calf or golden cow solutions. And if you think of the world that way, you realize the world is forever evolving.
Yep.
20 years ago, if I were to tell you that Linux would run on more computers than Windows and would run on a foreign planet before Windows, you would laugh at me. But see where we are in 2021. It takes time.
Speaking of the golden calf of DevOps or IT right now, let's really call names, right? So when we're talking about Kubernetes, let's talk about containers. Let's talk about like where are containers synonymous with DevOps? They've seemed to become an easy way for development to go across the gap to ops, right? But is this just a handy wrapping an envelope that's with us today? Or is this a long-term solution to all of our needs?
So, you know what? I don't know the answer, but I do know that Solaris had zones a long time ago. FreeBSD had zones for a long time. And then like even think about if you use an iPhone, those applications are pretty much walled off of each other. I think that the concept of containers, whether they be C groups, well, they'll be C groups for the long time. And
right.
In Linux, I think that's not going anywhere. Now, Docker and containers is how we think about them now.
Yep.
I think that's actually something that we will not talk about as much in the future. Let's say if we go out, 18 to 24 months, because that just becomes how we do the thing. And if we go back to how I was thinking about developer experience and operator experience, we don't think about how our linker works whenever we run GCC. In a lot of cases, none of us run GCC. We run make. Oh, I'm sorry. We don't even do that anymore. If we're on a Mac, we just use Homebrew and we don't compile anything.
Yep.
Or if we're running Xcode, it just does all the things. So understand at the end of the day, you likely have an autoconf or a CMake process running. You have GCC running in multiple languages. You have a linker. And if you're using in this newer technology, you probably are linking to a different format, and then that gets linked to your machine code. And we don't think about that anymore. I think that containers will be pushed down over time, that we don't think about them. We can actually rationalize the world from our applications rather than our tooling. And that's where we want to be.
How much is it, as someone, so we'll level set, recently dealing with some customers who have been using GCC, and using GCC based on an Alpine Linux container, and running into issues with the GCC that's shipping with Alpine Linux right now. It's not what it's not GNU, or it is GNU, or something about something that's causing issues. But we've gotten to the point exactly as you push it down in the tech stack, it is what it is. But then when that tech stack breaks, right, it's like you're now like going deep in the weeds to figure out what's broken. How do we balance? Is this DevOps an SRE's job to balance what is now deep in the infrastructure of the tech stack, or is that another role entirely?
No, I think that will become part of that. So a lot of people were using Alpine and ran into the muscle issues because it was not real glibc.
Yep.
But think now that Google has their small container images that you can use for a base, and they're much closer to the glibc that everyone thinks about, and they're super tiny.
Yep.
And the way that we couldn't get there on the first step, that was like a third try. So what we're seeing, but the reason that we got there is because we learned the mistakes.
Yep.
Now, who's going to be responsible for that? I think that over time, well, actually, I think that every person who thinks they're an ops person should know how to write code. And I also think that people who write code should understand the platforms where their code runs. And I think what we're going to see over time is that those platform or those two people are going to, at least for the general case, are going to merge a little bit. And there's going to be much more overlap. We're going to see people who are comfortable writing code and deploying it at some level.
Yep.
And just one last thing there, and then the higher part and like the harder part where you deploy at scale, that will be the specialization. Because deploying to 10 hosts versus deploying to 100,000 hosts, it's a different problem.
Or you run into an issue, and again, but to push back a little bit, right? You also run into an issue now where, while we're progressing our lightweight base images, right? We've got this coming out, but you've got a rover running on Mars, or you've got a space station running, out in space it's running like kernel 2.14 or whatever the heck it is, and is not pulling down the latest base images that we're pushing out. So does this tech, we build tech faster and faster, it seems. Are we building more mainframes? Are we building more Pascal? I think in
we are.
There's always use for these old languages and for this old experience. Are we just making that problem bigger at scale?
We are. And people have problems with change. They're saying, oh, we're always inventing something new. Well, that's great. And here's the best thing. What was the top hip hop song in let's say November of 1993? I probably could tell you if I just really thought about it. It was probably The Chronic from Dr. Dre. What was the fifth? Who cares?
Right.
We only remember the winners. But for there to be a winner, there's going to have to be a lot of losers. And we're going to have to continue experimenting. Kubernetes was not the first major exploration of running containers at scale. We had the Mesos project, and Mesos with Marathon, and Mesos with Aurora. And then they had, we were actually running containers at scale. And what we realized is that having two schedulers actually made the world harder to run. So the world kind of coalesced around Kubernetes. What I think will happen with Kubernetes over time is that we'll realize that the API is the good part. It's a API, it's declarative, it can be extended. I think that pattern will actually jump out to more places where things aren't Kubernetes, and then maybe in the distant future, Kubernetes becomes a Kubernetes style API, and there is no container runtime anymore. That's just an extension. And you know what? We couldn't get there just by saying we're going to do this. We had to start with Docker, or actually we had to get C groups into the kernel, thanks Google, and then we had to have the Docker folks experiment. Then we had to have that integration with Mesos, and then we had to go 7 years of Kubernetes to get where we are right now. And I say that's a long time. I was in high school when I wrote my first Linux kernel driver, and I graduated in 1994. This is a long journey. We're going to have wins and we're going to have losses. What has more wins is going to actually push us further, and we should just shed the losses, but understand that we're not smart enough to get this right.
So as an engineer, or someone who would once have called himself an engineer, right? As someone who is engineering today, right? As an engineer, we have the opportunity, I should say, to over-engineer things, right? Mm-hmm. We talk about tooling with DevOps and people interacting with tooling, but a lot of what we talk about, right? You talk about a Kubernetes-style API. This lends itself to automation. How do you know when to automate and when not to, right? Because there's going to be many, missteps along the way. How do you prevent from going too deep into a technology that may just be a stepping stone to something else?
Oh, well, when do you automate? All the time. I was noodling on an idea this morning, and it happened to be Kubernetes. So I wrote some YAML by hand. I applied it to the cluster by hand, and then I deleted it to the cluster. I put it in a makefile. And you're like, why didn't I use Kubernetes tool? Well, this was easier. And then I wrote 5 more things. And then I actually used a Kubernetes style tool to put this together, but was ran by a makefile. We should constantly be automating and constantly be thinking about how can we remove things from our process that don't make sense. And the only way that we can push ourselves further is with this level of automation. Like this morning, I was using makefiles. Whenever you're deploying your applications, one of the first commits should be that commit, even if there's no code in there, that actually submits it to the CI system and runs a /bin true. That's it. And at least you can see that once I do a commit to, GitLab, because we're talking about everybody today, at least I am, and then it goes and it hits your Jenkins or it hits your GitLab pipelines, that it runs and it gets a success. Yep. So now, whenever you do your second commit that has code in it, guess what? You're not wondering, well, what's broken? Well, it's obviously my code because it worked with no code. And I think that if we approach everything that way, it's a very incremental way of approaching everything. What we'll find out is that the things that are great stick, the things that aren't, they don't stick. But guess what? We don't lose anything because we've automated. And I'm sure people listening now or in the future are going to be like, oh, how do you automate? And that's actually where we should be focusing. So if we're thinking about DevOps and we want to have a practical application of DevOps, it's literally automate all the things. Like, let's figure out how to automate everything. And I'm not just saying use a makefile. I mean, we have Terraform, created by a friend of mine. We have Chef, created by a friend of mine. We have Ansible. He's now a coworker. No, actually, I do know the person who created that. We have Salt, coworker. But think about the world through automation. And because we're humans and we're fallible, or we're not infallible, we need to rely on our tools and have a great set of tools, because from small abstractions, we can build big abstractions, and then we can tie them all together. The only thing that I would caution you with is that don't think of DevOps or anything else as a juggernaut. It's a collection of practices and tools that we tie together in ways to create something bigger than the whole. It's not zero sum.
So
yeah.
Along those notes, right? I mean, it's crazy to think about in 2021 that there's someone watching this right now saying like, I need to get on board this DevOps thing. I think it's time. But like, we know that exists, and it's not that they don't know that DevOps is what they want to do. They're working on a system that has been stuck in a world that didn't allow them to like take that journey until now. We just talked about automating everything and how that's where we need to go. But like there was some notion, and I can't remember the exact words you used, but like there also is how we get ourselves out of problems. How does moving into DevOps today, moving into automation today, how would that fail, right? Like what does failure look like to you on a DevOps project?
Well, what does failure look like? Well, failure looks like everybody quitting and giving up. That's my bar for failure. I think that in any process, you will have ups and downs. Hopefully, you have more ups over time so that you can have some level of success. But what I think one of the things, the failing indicators is not taking what you've learned from your project and your space and employing that in your solutions. And what do I mean? Well, you can go on to Twitter, you can listen to me. I've dropped a lot of product names here, and you can try every single one of those out. You can go use all these fancy observability and tracing companies, and all you're going to be doing is giving them money. What you need to first do is on your path to success is figure out, well, what your goals are. And that was what I was talking about with actually tracking these metrics. And just a little pointer is that I mentioned computer metrics, but and what we do, we're all coders for money or operations people for money. Everything has to have a business impact. So everything needs to revolve back to the business. So sales and other leading business indicators should be taken account whenever we're building out whatever is called DevOps. Because if we exist in a vacuum, then we're probably going to be a net negative rather than a net positive to the organization. So I'm actually just answering the question from Robert Lowe, trying to tie it into this answer. So what are my thoughts on including business metrics into your DevOps goals? Yeah, 100%. We should be doing this. Yes. So that's how I think about that.
What along those same lines, right? So if projects fail at the end of the day by not meeting business goals, business metrics, right? What makes DevOps projects fail, right? Is it over tooling, under tooling, training, non-training, a combination of them all, right?
Yeah, keep on going, because all the things you just said were those things.
Yep.
All of those things. But what I think it goes back to what I'm always going to say, not having a common goal and a vision is what makes things fail. Because if you have an engineering team, and let's say we'll just have a fictitious one. So small company, you have a CEO, or smaller company, you have a CEO, you have some kind of leader of engineering, you have some kind of manager engineering, and then you have an ops team, and then you have a dev team. If all of those people are not aligned on with the same vision to have the same set of successes, then they're all going to go in different directions. Because the ops team are saying, you know what, we need to deploy to AWS because resource manager at Azure is gross to us. And the CEO is looking like, well, hold on, Azure is giving us, $5 million in credits. I don't want to spend that money.
Templates are the future, right?
Yeah, that's a feature, not spending much money. And then you have down at the operations level where I want to use Prometheus. And with engineering, they're using, let's say they're just using Java 8 and they can't find they're not actually exposing metrics. No, we want to expose metrics through JMX. Notice that everybody is not aligned on what needs to happen. The goal is to deliver this application in some amount of time to our customers with some amount of profit. And that's how we should do it. That's how DevOps or literally anything else fails, is because of lack of alignment.
Do you think it starts top down, bottom up?
Everything, yes. The fish sticks from the head. And I wish I could say it in Italian because it sounds so much sexier in Italian, but the fish sticks from the head. Organizations fail from the top. Don't let anyone ever tell you they don't. If your team is failing, it's because the leader is failing.
What's the advice you'd give to a leader who's failing with DevOps right now?
Depends on. So my advice to leaders is leaders have two responsibilities. One, they need to look up to understand the vision that is coming down from above and the goals and the mission. And two is that they need to look down to make sure that they are translating that vision, mission, goals, and strategy into whatever team is below them in a language that they can understand. So that explanation is going to be, VMware, so we have a CEO, and then we have a COO, and then we have business GMs, and then we have senior VPs and VPs and directors and managers. It's ridiculous. It's crazy how big we are. But at every single level, that conversation is a little bit different as you translate it down. I'm talking to a team who are implementing one feature for a product. I'm explaining how their bit fits in the goal. But if I am a COO talking to a senior VP, I'm explaining this, but I'm also giving you the financial impacts as well. It's the same conversation, but it's tailored to the audience. So a leader looks up to understand where they should be and looks down to explain how they're going to get there. And that just goes down through the stack.
That is wonderful, insightful advice. As we've talked about tools a lot, right? We've mentioned about every tool that's out there. What's the latest DevOps tool that you're into today? And what's the latest DevOps tool that's a fad? Not asking you to put anyone on blast, but kind of put them on blast.
I have no problem with that because I'm like the highest ranking of engineers in my company. I've won, so I'll say what I want. Nothing you can do to me. Okay. So something that's a fad right now is these fake developer experience tools. And what do I mean by that? Well, they're tools that are positioned to help you deliver software better, faster, cheaper, but they don't do it from the direction of helping you hit your business goals. They provide you just another tool set of things that you have to learn. And this is not a new fad. This is a common fad over the last few years. I've been guilty of this. Mistakes were made. I think that this fad of instead of, we need to work on business context and bigger problems and actually more flexible solutions. A good example of this would be, shout outs to my friend at Google. I'm not making fun of you all, but I do want to bring this up as an example. Great piece of software. It's customized for Kubernetes. For the people who don't know, it's a way to generate the YAML that you would want to deliver to your clusters. And the good part about it is that it actually understands the YAML. So if you want to change container images or inject other things, it's great. The problem is that it's very terse and it doesn't lead you to anywhere. And because it doesn't lead you to anywhere, it pretty much leads you to nowhere unless you know what you're doing. And it's not a bad tool in any way. It's a great piece. It's a great tool. Another piece of tooling, like in the Kubernetes space, would be Helm. Same thing. Great. It's a great tool, but don't hold it wrong. It'll hurt. And I think that what we're learning, and this is not bad, this is what we're learning in this space it's what I said earlier. We want to lead with our solutions, but we didn't understand the problems we were trying to solve. And what I think needs to happen now in developer experience space is that we're still in this research phase of understanding. So we're thinking like Kubernetes. Actually, who cares about Kubernetes? And the fact that we care about it so much, we should be talking about, like we talked about serverless, talking about serverless patterns. Mm-hmm. But when people want to talk about the patterns, they give you this crappy piece of software to use to do this pattern. I'm like, no, I just want to talk about the patterns. No. Like, how do I run this type of site with this pattern? And I think as we understand the space more, we will start moving more into this whole pattern space. And I'm not saying that we should just rely on patterns, but we still don't know what we're doing. We are neophytes. We're new at this, and we need to be better.
I think it's hard, though, as I talk to leaders of the industry who know enough to make progress, right, but are still trying to understand what's going on. Kubernetes has seemed like a long-running pattern, right? I mean, it's in the scheme of things, like sure, Linux has been around for however long, right? But like Kubernetes or Docker scaling and orchestration has sort of been around in the fast-moving tech timeline that we're in today for generations, right? So I feel like it's hard for people to recognize that or people are struggling to recognize if it's a pattern or not versus if it's a technology to stay.
Yeah, well, you know what? If someone knew the answer for that, they'd be a billionaire and they would be off sipping Mai Tais and doing whatever billionaires do. That's the reality. What's the answer? I don't know. So just a little story here. Years ago, I knew this guy named, we call him Defunct, and this other dude, TP Dubs. I knew them. I hung out with them. Like, we're going to create this company. And they created this company. They hired some more friends. And they said, you should come use our software. And guess what? And, today is March 3rd of 2021. And this company was GitHub. And look, now we're having this conversation. Think about SourceForge before that. We used SourceForge and thought we loved it but we didn't know. And it took Tom and PJ and Chris to actually figure that out. So what I'm saying is that, if some people are looking for answers, what I'm trying to show you is how to ask better questions and recognize what failure looks like. And then over time, we get better answers. We can't just say what's great. And that's the easy thing. Like, oh, what's the best thing I should do? I don't know. I don't know your stack. But here's what I would think about. If you're thinking of distributed computing, what do you think about CAP? Are you CA, AP, CP? Let me know. And that's what we need to get better at. But what we need to do is make those patterns more accessible. But the problem is we're still learning. It is as we learn, the patterns get more and more accessible. It's coming. It's just gonna take a time.
You talked just then about understanding the questions you're trying to answer, right? And really understanding the context. I want to set you up here. When we were prepping for this, you told me a story about how you ran Kubernetes on a large number of non-servers. Well, they're probably servers, right? But
they're definitely servers.
Yeah. I mean, they're definitely servers, but they're not in a data center somewhere. They're not sitting in Loudoun County. No. They're not sitting in the Bay Area or wherever the heck servers typically sit. Want to talk to us a little bit about what that experience was and how that became your solution.
Okay, so what Jamie is bringing up here is that at VMware, I am the architect in our telco for our telco platform. People are like, VMware does telco? Yes, we're like a 35,000 person company. We do everything. But we actually are having some success in telco. And why is because this new world where you go from 4G to 5G. Why is 5G so important? Well, it's so Bill Gates can track you. That's really, no, I'm just kidding. It's not what it's about.
Or are you?
Or am I? Take that for whatever you want. But why 5G is so important is because it's the first time in history we can run our entire telco stack in software. You're like, what? It didn't run in software? No, it does not run in software. Vendors out there for years ran it as hardware. You would just buy a box. And why is that important? Well, it's important because all the gains that we've learned from cloud native and distributed computing over the last few years, we couldn't apply to telco, but now we can. So whenever we say that, I run, tens of thousands of Kubernetes clusters across the country, it's because, when you think about a large telephone company and you look up and you see a cell phone tower, within a kilometer or two of that is going to be a computer. And with 5G, it's going to be a big computer. So think that with 5G now, you think, oh, I can get a gig to my phone. Well, at the cell phone tower, there's going to be a antenna up top, and there's going to, out the back, it's going to spit out 25 to 40 megabits gigabits per second. And below that, there is going to be a software. It's called the radio access network. And what it does is it processes it, takes a signal, and it makes it into a networking signal. And you're thinking, wow, what does that have to do with Kubernetes? Well, because we're running this software using these cloud native patterns in a distributed fashion, what we realized is that Kubernetes was actually a great match here. So in the future, a lot of your major telcos are going to be running Kubernetes there. And every time you see a cell phone tower, and if you're a big vendor in this country, best believe, they split it up, but there's hundreds of thousands of cell phone antennas in here. And the type of scale that we're talking about, in a particular blast radius could be, 10, 20, 30, 40, 50,000 poles. And we're running clusters across all these things. And so why is that neat? Well, it's neat because, first of all, it's neat because, commodity hardware can be used to scale these things up. These are no slouches either. So, these are like dual CPU, many cores, a literal butt ton of memory, and lots of NICs, actually, lots of network interfaces, lots. But why is this important? Well, it's important because, like I was saying, we can apply these things that we've learned throughout the years. Like whenever Jenny was talking about, yeah, I've seen cloud from ISP to where it is now. I've worked in it. I've touched it. Why this is interesting is because we've been able to take these lessons that we've learned, and now we run at real scale. Like Amazon has scale. Amazon with all their data centers, they have scale. But someone who rivals it is, let's say, whoever your telephone provider is. They rival it. Oh, do they ever rival it? And there's going to be a battle here somehow in the future with the hyperscalers versus the telephone companies. But I'm right in the middle, and it's great because it's nice being able to take a workload that it can only run within a kilometer or two of the radio tower. Why? Because we actually have microsecond latencies here, and we can actually push that out to somewhere else.
Yep.
Or we can take applications like what's going on now, like with manufacturing or self-driving cars or other things, and we can actually take those applications and they don't have to run in data centers anymore. They can be pushed out. Or we can take like a company, like your company could start providing its own 5G service for whatever, or because it doesn't want to use Wi-Fi 6. That's amazing, but there's software running, and that's what I work on now, and it is at scale. It's crazy scale. But the good thing is that I'm the architect, so I don't get paged. So I guess it's somebody else's problem. I'm like the anti-DevOps person.
You're not climbing a tower. You're not like that is not the pager I want to hold, right?
No, but I do work with my teams to make sure that we have great process. And like I said, you look up and you lead down. And so I'm distilling that problem for engineers who are solving this problem. So it's a neat thing. It's different. It's not enterprise at all.
Yep.
So it's what I do.
Well, what's interesting, right, is I said a little tongue in cheek, right, earlier when I was talking about DevOps and who's adopting DevOps in 2021. But the reality is, it's like you're pushing DevOps, you're pushing containerization, you're pushing software out to the edge, right? And we have this advantage. There's an article I read 2 or 3 years ago, right, about how Chick-fil-A is installing Kubernetes clusters like in their restaurants. It's the ability to push software, to push technology, to push this out to the edge, right, truly is creating opportunities for software and technology that didn't exist before, right? And that's where this can all continue to happen.
No, that's true. The DevOps thing. So with one of the operators we're dealing with, actually, one of the things that they're saying is that they want to be able to do this DevOps thing. They're asking for it. They don't like the idea where in telco land it takes 6 months or a year to deploy software. Literally 6 months or a year to deploy software. They said, I want to upgrade this now in this region, and with 5G, there's new things you can actually do this. They want to see that. So we're actually pushing these DevOps principles out to these telcos, and they don't know, but they want to learn. And I guess if you want to say, well, what's so good about DevOps? Well, DevOps gives us something to rally around that looks like success.
A language, a context to share, right?
Yes. So that's what DevOps is. DevOps is, it's our rally flag. It's our context that gets us to a better place. Now, how do we implement it? Well, that depends on what your environment looks like. That's a conversation. But the idea that that you can actually have this relationship between a development and an operations practice, you can go from day 0, day 1, day 2 deploys, and it all works together. That's what DevOps is. And that's what's amazing, and that's why there's books about it and conferences, and we're talking about it today. That's why it's a big deal. It's not a thing; it's a new way of thinking, and it's not even new. It's 10 years old, so it's not new. Actually, now this year will be 12 years.
Yep, 12 years. So we have now gone full. Like we couldn't have wrapped this up any better, right? We've gone full circle all the way back to what is DevOps and how it's still applicable, still valid, still really pushing frontiers and pushing the edge even today. Before we wrap up, Bryan, thank you for all of the time today. Thank you for all of the answers. This has been great. You've been very exciting to hear all that you've had to share and all of your experience. I did want to ask you a couple of quick questions. I want to kind of hit you in lightning round, if that's okay.
Fine.
Jenny mentioned in your bio, big into movies. What's the most recent movie you've seen?
Last night, I watched the Notorious B.I.G. Biopic on Netflix. I only went till 18 minutes because I didn't want to see him die. I thought I'd cry.
What's the Best movie. What's your favorite movie?
Friday.
Best,
Came out in 1997.
best movie.
Friday.
Okay. Tech podcast. Do you listen to any tech podcasts?
No.
Non-tech podcast.
NPR has a few good ones. I like ones that talk about the world as it is rather than the world as we like to describe it. So history lessons and why the world is like it is today. So that's what I like to listen to.
Tech influencer. You've mentioned a bunch of names throughout this talk, right? You're not opposed to name dropping. Who when they post something, when they say something, you're like, oh, I should check that out.
All right. I'm only going to mention two people right now. I'm going to mention Kelsey Hightower. And people are like, oh, yeah. Actually, we're friends. We talk. So I will always talk good about him. But another young lady I want to talk about is Angie Jones. And she goes by Tech Girl 1908 on Twitter. We haven't met in person. We will one day. But I love the way that she looks at the world.
Mm-hmm.
And it's extremely technical too. Love that.
Most recent side project.
I'm writing a
because what you did this morning, right? You said you were doing something earlier on.
That was work.
Okay, work.
So most recent side project. Well, the most recent physical side project is I'm rebuilding my home lab. I have a literal butt ton of cores, a little butt ton of memory, and I'm rebuilding that. But coding project is I have a super secret Kubernetes thing that I'm working on in Swift.
Super secret Kubernetes thing in Swift. And with that, what's your Twitter handle so people can follow along when when your super secret Kubernetes thing in Swift comes out of stealth mode?
It's BRYANL. Yep, Bryan L.
Bryan L. There you go, Bryan. Thank you for the time this afternoon or morning or evening, or if you're watching this on demand, whatever time it is in your neck of the woods. Thank you.
Well, thank you for having me and working with me.
No, this has been great. Jenny, over to you, man.
Wow, Bryan L. I think you just became my favorite speaker. You have a way of describing things with such unique perspective, yet with so much clarity in there. From leadership advice to anecdotes from tech company histories to toolings and patterns. That was just a feast of all things DevOps. And thank you, Jamie, also for the inspiring questions throughout the session so the audience can get a glimpse of all the accumulation of knowledge and expertise that Bryan Liles has, right? Really. Gentlemen, I very much enjoyed the session. And my only regret is that we didn't schedule a longer session with Bryan. And as Bryan said earlier, we only remember the winners. And both of you are definitely winners in my book.
We'll have to have Bryan back. We'll have to thank the wonderful friends he has at GitHub who suggested he come. They are also the winners here. Thank you, Nicole.
Yeah, Nicole. Thank you, Nicole.
Shout out, Nicole.
Thank you, Nicole. And as unwilling as I am to do so, it is time to wrap up today's session. And let's take a look at our schedule for the days ahead. For tomorrow, we have an interactive roundtable style discussion on improving DevOps tooling and infrastructure with GitHub engineering and product leaders. Reminder, that is a session, the only session that won't be recorded, so please tune in live for that one. On Friday, we have a tactical deep dive and demo of automating CI/CD on a single platform with GitHub Enterprise. And for a reminder for anyone who wasn't able to join the whole session or some of the sessions this week, all of the sessions will be recorded and available on demand at infocus.github.com. And as I said earlier, the only exception being the roundtable. So because we want to keep that as intimate of a chat as possible. And before we wrap up here, folks, if you like a deeper dive on anything we covered here today, just click on the Contact Us button on the top right of your screen, and we will get back to you to set up a time to chat. Lastly, please just take a minute or two to complete a short survey about your experience with us today. It is very important that we hear back from you because we designed this program for you and want to continue to raise that bar for you as well. So please don't be shy and let us know what you think. And with that, Thank you so much for joining us and looking forward to seeing you live tomorrow.